So today the topic is Backporting UI Collection View Compositional Layout. And the speaker is his name is Katsumi. Okay, so Katsumi has been developed native iOS Mac application developer. He also developed like major iOS applications and also maintains some popular open source libraries. And you can see what his topic is, right? He's usually developing like small tools for like developers. So today we're very excited to invite him to share what he's gonna share on whatever he developed. Okay, so I will give the mic to you. Thank you.
Thank you. Hello, 你好。こんにちは。I'm Katsumi Kishikawa, an iOS engineer. Today, I'm excited to talk to you about Collection View Compositional Layout. It is a new API introduced iOS 13. It is an entirely new mechanism for building custom layout for collection views. It's very powerful and flexible. You can easily make any layout without bugs. It's amazing. It just grabbed my heart when I watched a session about it at WWDC this year. But this wonderful API less known than I expected. So today, I'm going to share what the Collection View Compositional Layout is, and I will talk about that problem that the old ways have so far, and how the new API will solve them. Then, I will explain how it works, and I wanted to use this wonderful API in production right away. So I ported it to iOS 12 and older versions. So finally, I'm going to share some technique to backport it to earlier iOS 12. Yes, let's get started. First, what is Collection View Compositional Layouts? Collection View Compositional Layout is a new API introduced by iOS 13. It makes extremely easy to build custom layout for collection views. It's a completely different approach, and it's easy to use and hard to mistake. Also, it has powerful features that makes it easy to achieve complex behavior that modern apps requires. In WWDC 2019, Apple says their own App Store application has been re-architected using Compositional Layout. Thanks to Compositional Layout, he says their code base can be significantly simplified. Maintainability has improved. Also, his aspect of the collection view has completely changed. So let's see the App Store app as an example. This is the App Store app. The App Store app has a typical modern app UI. The layout of this app is very complicated. Various sizes content should be displayed on a scroll view. Also, in most cases, nested scroll views are required. It looks cool when the scrolls are nested vertically and horizontally. It's making people think that app is a cool and modern app. So nesting scroll views orthogonally are often required to make your app look very modern and cool. So how do we make such UI? There are multiple solutions, for example, using the multiple collection views, or stack view and scroll view, or build custom collection layouts. Each solution has trade-offs. collection views on collection view is much simpler than building custom layouts. However, data management and reusing cells are dramatically more complicated. Building custom layouts seems the right way, but I never want to do. Why? Because building custom layouts has a lot of problems. People who have made or people who have tried to make it may know. What the problems? What should I do to build custom layouts? What should I do to build custom collection view layouts? It is subclassing UICollectionViewLayout, then override methods as needed. That's it. It's a piece of cake, right? Unfortunately, no. I will explain what the problem with building custom layouts is and why I don't want to do. To create custom layouts, subclass UICollectionViewLayout, but UICollectionViewLayout is very abstract class. So we have to implement everything ourselves. UICollectionViewLayout doesn't help anything to calculate the layout. There is just an empty method to override. You have to all the layout calculations and prepare yourself. The code here is an example of the UI collection view interface. It has many methods. Most people don't know where to start. What we should do? We don't know the right way, and it is error-prone. So we are forced to try out error many times. Therefore, an implementation cost becomes too high. I'm pretty sure that is not what we wanted. This figure very roughly shows the implementation costs of each solution. Also, the layout complexity that each solution can produce. So which way do we use? Collection view flow layout can be used easily. But the range it covers is not big. It is difficult to build a complex layout using only that. Other solution, the way of nesting collection views, called the collection view on collection view, can be used to build a complex layout. So most people tend to choose a way to nesting collection views, because another solution, building custom layouts, are too early to use us. However, it should become much more difficult managing data sources and managing each scroll offset. UI event handling is more complicated. So this solution become much more difficult and hard. Then the compositional layouts appear this position. You can easily create any complex layout and easy to use. I even think that all views can be built with the compositional layouts. Probably. So up next, to show that my opinion is correct, let's see how the collection layout works. Let's see how the compositional layout works. Let's go back to the App Store app example. Please think, how long does it take time to develop such UI? Maybe 2 weeks? 1 month? Using compositional layout can be done in just 5–6 hours. I will explain how to build a layout with compositional layout. Let's see these three kinds of components as example. There are four important parts in the compositional layout: layout, section, group, and item. Composing these four parts can produce any layout. There is a layout. There is only one layout as the outmost container. A layout can have multiple sections. Section has multiple groups. Groups also can be nested indefinitely. There's no limit for nesting. This brings tremendous flexibility. Group has items. Items are smallest unit that makes up a layout. And each item corresponds to a cell. Eventually, the position of the item maps to the cell position. Like that, the compositional layout can produce any complex layouts to compose these four parts. It's like just configure the implement. Let's try it out. Return to the example. A collection of components of the same kind can be represented as section. There is only one group occupying the whole width of the section. The height is fixed. The group contains a single item. The item occupies the whole width and height of the group. The code that achieves this layout looks like this. To the details, the item I just explained is created programmatically. Also, a group is created in the similar way. The group contains the item. Also, section has the group. When creating an item or a group, specify the size for them. We can use relative value to specify the size from the container, which provides great flexibility. In this example, the width and height are specified as 100% of the group. This means this item will be the same size as the group. If the width is set to 0.5, we will be half the width of the group, and two items will be placed in the group. For the group, the width specifies the same as the item fraction width 1, so it is the same as the section width. On the other hand, the height is specified as absolute 50. Then it will be 50 points height regardless of the size of the container. Basically, this is all. You will find it very simple. You may think that using flow layout is easier or prefer nesting collection views. Please wait. A compositional layout can produce any layout just by composing them. In other words, no matter how complex the layout you create, the code complexity will not increase anymore. This means this is the upper limit for code complexity. So there are few bugs because it is just config, not implement. We don't need to write any complex code. Let's see other section. The code is very similar to the previous example. Only the size settings for the group are slightly different. The height is 40% of the container. Specify the width with 92% so that you can see the next cell a little bit to indicate that it can be scrolled horizontally. How about another section? A group has multiple items. There are multiple ways to specify the size when a group contains multiple items. In this example, specifies number of the items in the group so that the size is automatically determined equally. This method is useful when the number of the items that the group contains is fixed. This is because the framework will automatically calculate the size that will fit exactly. We don't have to think about how much size to specify to fit into the group. All that remains is to composing them. Return each section object correspond to the each section index. When all layers for each section have assembled, it looks like this. Compositional layout determines the shape of the layout that is mapped to the cell. And the data flow is along the shape. Having such an image makes it easier to understand. So layout shape is here and the data source is independently there. Just data flows to the layout shape. This image is very important to understand. Once this image is clear, you can easily code more complex layout for another example. The layout above is used in Photos app. Just place items in nested groups like this. If you create such a layout yourself by subclassing UICollectionViewLayout or using for layout, you have to write complex code that interact closely with the data to determine the size of each cells for each index. As you have seen so far, the compositional layout represents any complicated layout with composed of 4 parts. Therefore, the code complexity does not increase. You can keep your code simple. We no longer need to implement the UICollectionViewLayout. That's so cool. You think so too, right? Okay, I forgot to mention a very powerful feature for modern app. In the current state, all cells are arranged vertically. Remember, the identity of a cool modern app was a nested scroll, right? The correct compositional layout automatically generates nested scrolling by setting just one property. Orthogonal scrolling behavior. when this property is set, the items overflowed are automatically rendered on nested orthogonal scroll views. It's done automatically by the compositional layout. It's so cool feature. Orthogonal scrolling behavior property automatically extends the scroll axis in the orthogonal direction. No longer to place collection views on per collection view and write complex code to manage them. Simply handle simple single collection view and data source. That's amazing. So far, we have seen creating an App Store app UI using compositional layout. Is that true for Apple says the code becomes simple and surprisingly easy to create? Yes, that's absolutely true. I actually tried it. Here is a clone of the App Store sample app I made using compositional layout. This is just only a layout, but if you create this layout with old way or something collection beyond collection view, it takes more time or more day, weeks, I think. But it was able to make it 5-6 hours. This project is published on GitHub, so you can see how the code is simple and easy. I'm sure you all think it doesn't matter how now. It doesn't matter now because it can only be used on iOS 13. So it will be usable in 2 years. 2 years later, we will be migrated in Swift UI. No, you can use it immediately. I created a backporting library to earlier iOS 12. It is called UICollectionViewCompositionalLayout. Please try UICollectionViewCompositionalLayout. The repository shows various complex layouts as sample code. You can see how easy to write any layout, and it works on iOS 12, 11, and 10. Thank you. Thank you. But it is still under active development, not fully supported functionality and lots of bugs left. But it's very helpful even now, because App Store clone app I mentioned, it works perfectly on earlier than iOS 12. For example, a layout has such complex headers and footers won't render correctly in my library. But do we need to be able to create such layout? I think no. I have no experience to make such layouts so far. Since I can create an App Store layout clone, it can probably cover 90% of use cases, I guess. The most interesting part of this library is that it provides a complete drop-in replacement. It provides emulated implementation on iOS 12 and below. But if it works on iOS 13 and above, it automatically switches to the original implementation. In other words, there's nothing to do when you would omit support for iOS 12 in the future. No problem if you forgot to remove this library, because this library does nothing on iOS 13. To develop this library, first I copied the all interface from UIKit headers. Then I gradually implemented subclass of UIViewLayout. In shouldInvalidateLayouts method, it returns a value whether invalidates previous layers, and we calculated the layout again. In prepare method, calculate all positions of the cells, and layout attribute for item, and etc. Method return the position for cell on demand. The first challenge was the nested groups. It was overcome by implementing the layout calculation method in a recursive structure. Another challenge was orthogonal scrolling. As a result, it was surprisingly easy. It works just by creating a new collection view internally and pathing a layout that changes scroll direction. This implementation is so smart without using black magic such as method switching and so on. So please read the code if you are interested. Okay, wrap up. Collection view compositional layout is incredible. No need to implement collection view layout subclass, like just editing configurations. Keep your code simple regardless layouts become complex. And you can use it now without iOS 13. It's such great API, but there are some problems now. There is still no documentation. Even Xcode released officially today. No documentation, completely no. I can't understand what class is. All I learned is many times I trial and errors. But fortunately, we have to. We can read some header comment from the UIKit. So we have to code with only on header comments or WWD session videos and few sample code. But the sample code or various sample codes available from my repository is surely a great help to you. One more pitfall I found is the behavior of these APIs is not documented at all, but so I found there are some settings that don't work well. When stepping on such a trap, you may see a warning logs at the Xcode console like this. It says these combination of property doesn't work and don't use it. Yeah, so using this API, you should carefully see the Xcode console or something signals from UIKit. Okay, if you are interested in compositional layout, listening to this session, please try it. And my GitHub repositories have lots of examples. If you'd like to learn more about the concept we discussed today, I strongly encourage you to check out the Advanced in Collection View Layout session from this year's WWDC. I hope this talk will help you develop your app to be made cool in the future. It's been an absolute pleasure to speaking with you. Thank you for your time. I hope you enjoy the rest of your conference. Thank you.